Agarwal this side. I am a software engineer in one of the FANG companies, and today we are going to discuss one of the question that was asked in the Leetcode's weekly challenge that happens every Sunday. If you are watching from India or somewhere else, it's basically 8 a.m. India timing that we have this contest. So this was one of the question, and I think it is a very good sliding window uh, question that we should be aware of. So it seems like a very classic sliding window approach. I'll quickly go through the equation and I can give a quick walkthrough of the solution as well. So here the requirement seems very simple, that there is a k value that is provided to us which represent how many occurrences of 1 are we looking for. And once we hit that mark of k inside a string, we'll stop and we will see what is the current length, and so on. So at the end of the day, we want to see what is the minimum length in S that we can find out which have k occurrences of 1. That's all. And there are some other conditioning as well, that if both of the string are same, we will sort them lexicographically. But when we are seeing lexicographically, we are saying that the shorter one will come first. In short, whenever we encounter that somewhere there is a 0 and somewhere there is a 1, the 0th one is lexicographically smaller one. So this was the question. Okay, so let me quickly give a walkthrough as well. So here what I have done was that I have started off with the first index. I have first of all, I initialized few of the variables, and then I started to loop over the entire string. Every time what I'm doing, whenever I'm encountering a 1, I'm incrementing my length until and unless my length is equal to k. So you can see I'm just catching up that what is the value that we have. If it is 1, I'm incrementing my length. If at any point your length is equal to k, then we will come inside this if loop. That means we were able to find 3 ones that we were looking for. So we will come here. So I have divided this question in small sections. So the moment we have encountered 3 ones or k ones that we wanted, what I'm doing, I'm trimming all the zeros that are present at the starting. So there is a small function for trim that we can look after, but in short, if I have to tell you right now, I'm just discarding, if I'm just increasing my j until unless we encountered a 1. The moment we encounter a 1, we'll just return. So this is what this function is doing. This is making sure that we are moving a j from whatever index it was earlier. We are moving it to the index where we have encountered our first one, or we have encountered our first one of that particular section of substring that we are looking for. Okay, so this is what this function is doing. Once we are done incrementing our j, we will check that is the current length that we have just encountered. If it is smaller than the maximum length that we have, then it's a no go or no brainer question. We can just update our max length and we can update our result. And result is something which we will be passing at the end, like we will be returning at the very end. So as of now, we can just store the our substring inside a resultant string, which just signifies that this contain a string which have k ones that we want. But if in case both of them are equal, that is the one that I just discovered is equal to the length which we already have. So how to differentiate? And this is something where we get a hint from the question that they are saying that if 2 strings are equal, we will return the lexicographically smaller number or a smaller substring. So I did the same thing. I declared a function with the name lexicographically smaller, and this function is doing nothing. It is just comparing 2 strings and returning the smaller one. Okay. So once this was done, we can say that we are able to save the smallest value to a resultant. And at the end, what I'm doing, there are 2 things that I'm doing. I'm incrementing my j. What does this mean? If you remember, what we did in line number 13 was we trimmed all the values till we got till we got 1 on the first index, or on the very first side of our substring. So we know that the first value that we have we know that the first value is definitely 1, because we have already executed this function. So if I'm going to increase my j++, I know I'll be discarding the first one that we have. So even if we are talking about this string, the first one will be this. So at the end of the day, we will be discarding this one and we will be decreasing our length. Why we are decreasing our length? So that next time when we encountered one more one, our length will be back to 3, and this condition will be true again, and we can follow up the process again and again until unless we reach at the end of the for loop, and we can just return this resultant. So this was a very small question, and I guess applying sliding window and knowing the basics of sliding window is very helpful. It is one of those questions that is very frequently asked. I have got a lot of sliding window related questions during my past interviews, so I hope this would have helped. I have tried to keep it short, and let me know if you need any other suggestion or any other feedback. Thank you so much.